Hello everyone, welcome to MindMatrix Learning. So in this video, we will be solving questions from GATE 2024 operating system subject from Set-1. So without waiting, let's start. So those who are new to our channel, my name is Anshul Sharma. I'm upcoming software engineer too at Juniper Networks. Currently, I'm pursuing MTech in Computer Science from IIT Kanpur. I have 2+ years of teaching experience and I have mentored more than 1,000 students as of now. I have the expertise in computer science and data science subjects. I secured All India rank 294 in GATE Computer Science, cleared ISRO NIC NILET exam, also got selected as Administrative Officer at AIC. So these are the premium courses that we have already launched on our website. So you can visit the website www.mindmatrix.net.in and you can enroll for any of these courses if you want to prepare for GATE Computer Science Complete Course 2025-2026. So this is the course for you. If you want to prepare for GATE DA Complete Course, so you can enroll in this course, or if you want to prepare for both GATE Computer Science and GATE DA, then this is the course for you. Apart from that, we are also providing a separate placement preparation course, and this placement preparation course is already included in these packages. So you don't have to enroll separately if you are enrolling in these complete courses for GATE CS and GATE DA. And the biggest announcement that we are providing operating system completely for free. So you can enroll in this course, and I can assure you, once you start learning, once you watch all the lectures, you will love operating system. I'm telling you this. And this is the highest quality content. This is the best quality content that we are providing for operating system. And if you really want to check our content quality, so you can definitely enroll for this course, and this is completely for free. Okay, so enroll for it, and let's start the questions. Let's start solving the questions. Before that, one more thing. If you want to join our Telegram doubt discussion group, this is the official and public Telegram group. You can scan this QR code and you will be able to join. You can also join our WhatsApp channel where you can get all the latest updates, and this is the QR code for our website. You can also directly visit our website through this www.mindmatrix.net.in. So here is the first question that we have on our screen. So let's start solving this question. So question says, which of the following statements about threads is or are true? So basically this is a MSQ question. This is an MSQ question, multi-select question, right? More than one answer may be correct. Okay, so let's read the statements here. So statement first says, threads can only be implemented in kernel space. Is this statement true or false? This statement is false. Why? Because threads can also be, when we talk about user level threads, they can be implemented in user space. So I'm writing here, user level threads can be implemented in user space using thread libraries. Using thread libraries, you can implement this in user space. You don't have to implement these user level threads in the kernel space. But if you want to implement kernel level threads, then definitely you have to implement in kernel space. And so that is the reason why this statement is false here, because here it is mentioned only be implemented. No, these user level threads can be implemented in user space using thread libraries. Kernel level threads can be implemented in kernel space. So that is why this first statement is false. What about option B? Each thread has its own file descriptor table for open files. Is this true or false? This one is false as well. Why? Because each thread has its own stack, each thread has its own register set, and each thread has its own program counter. Apart from these, everything is shared by all the threads of a single process. So each thread has its own stack, its own register set, its own program counter. Apart from this, everything is shared. If you talk about heap, file descriptor, code, data, everything is shared. Just these three things are not shared. Every thread has its own stack, register set, and program counter. That is why this statement is false, because here it is saying each thread has its own file descriptor table for open files. So this is false. Clear? Now, option C says all the threads belonging to a process share a common stack. Is this true? Just now I have explained you that each thread has its own stack, but here it is saying that they have a common stack. So this is also false. This one is false as well. What about option D? Threads belonging to a process are by default not protected from each other. This statement is true. This statement is true. So whenever you implement threads, by default protection is not there, because threads of a single process has to share data in between them, right? They have to share the data in between them, that means to each other. So that is why by default protection is not there. But if you really want to implement the protection, then developer has to do that. Then developer can write the code for a protection as well, and then the threads can be protected from each other, but by default it is not there. So that is why this statement is true, and we have to tell which one of the following is or are true. So here only one statement is true. Option D is the correct answer for this. I hope it is clear. So sometimes in MSQ only one statement can be the answer. Okay, it's not every time that more than one will be correct. No, more than one may or may not be correct. At least one will be correct for sure. So option D is the correct answer here. Let's proceed to the next question now. Second question says, which of the following process state transitions is or are not possible? Again MSQ question. Is or are not possible. So ready to running, running to ready, waiting to running, ready to waiting, running to terminated. So to answer this question, you need to look at this process state diagram. So if you see the first option, running to ready. So here if you see, this is the running state and this is the ready state. Running to ready, yes, it is possible whenever you want to preempt a process, right? When a higher priority process arrives, in that case, the lower priority process, you have to preempt it and you will give the CPU to a high priority process. So due to priority or due to time quantum also, let's say if you are using a round robin CPU scheduling algorithm, in that case, if the time quantum gets over for a one process, then in that case again context switch will happen and you have to give the CPU, you have to allocate the CPU to another process. So in these cases, that means you can say in case of preemption, basically you have to move the process from running state to the ready state. So can we say this is possible? Yes, this one is possible. So running to ready is possible. What about waiting to running? What about waiting to running? So here if you see, this is the waiting state, waiting to running. So running state is here. This transition is not possible. From waiting you can move the process to the ready state, not directly to the running state, because already one process might be running. Already one process might be running and you cannot just directly shift the process to the running state. Is it clear? So this is not possible. This is not possible. What about option C? Ready to waiting. So here if you see, ready to waiting, is it possible? Ready to waiting is also not possible. From waiting you can move the process to running state, but from ready you cannot directly move to waiting state. So this is also not possible. This is also not possible. What about running to terminated? Obviously it is possible. From running state, once the process complete its execution, definitely it is going to move to the terminated state, right? So this is possible. This is possible. So here if you see the answers, so option, we have to find which one is or are not possible. So option B is not possible, option C is not possible. So BC is the correct answer for this question. Is it clear? So all these concepts I have already covered in the operating system lectures, so you can enroll for it for free, and we have solved variety of questions on all these concepts. Let's solve the next question now. So this is based on synchronization, but it is a really simple question that they have asked. Let's read the question. Consider the following two threads T1 and T2 that update two shared variables A and B. So A and B are the shared variables here and they are initialized to 1. Both the variables are initialized to 1. Through context switching between threads can happen anytime. So that means we can we can perform context switching anytime. That means they are having concurrent execution. Each statement of T1 and T2 is executed atomically without any interruption. Okay, right? That means if this statement is running, it will be running completely, right? If this statement is running, it will be running completely. That means there is no preemption, I mean there is no interruption or preemption in between the execution of a single statement. So they are running atomically. Atomically means either you run all or none, right? Which one of the following options list all the possible combination of values of A and B after both T1 and T2 finish execution? So this we have to solve. So let's come back here and now we are going to solve this. Let's say I'm naming this as the first statement, this as the second, this is the third statement, and this is the fourth statement, just for simplicity, just to make solving this question in an easy way. Now carefully see this. What are the possible orders we can have? Let's say first T1 is running, so we can run the first statement of T1, then we can run second statement of T1, then we can run third statement of T2 and fourth statement of T2. So this is one of the possible order. What else we can have? We can run 1 here, then we can run 3, then we can run 4, and then we can run 2. This is also possible because concurrent execution is possible. What else? We can run 1, then we can run 3, then we can run 2, and then we can run 4. This one is also possible. If we start from T2, so I can start with 3, then let's say I'm running 4, then 1, then 2. This is also possible, one of the order. We can run 3, then we can run, let's say 1, then 2, and then 4. This is also possible. And what else? 3, 1, 4, and 2. This is also possible. So total 6 orders are possible here. And we have to find what are the possible combinations of values after these thread T1, T2 both finish their execution. So we have to find that. Let's start solving this. So here if you see, let's talk about this first order first. So initial value of A is 1 and initial value of B is also 1. So let's say first statement is running, A is equal to A plus 1. A is 1, so A is equal to A plus 1, it will make it 2, right? Then second, B is equal to B plus 1. Initially it is 1, so it will make it 2. Then the third one. So third one is saying B is equal to twice of B. So B is 2, so twice of B, it will make it 4, right? And then the fourth one you are running. So fourth one says A is equal to twice of A. A value is 2 now, so 2 into 2, that is 4. So here, if I'm following this order, so can I say the final values here, A is equal to 4 and B is equal to 4? Is this point clear so far? What about the second order? So here A is equal to A plus 1, so we are going to make it 2. Then third one, B is equal to twice of B. Now initially B value is 1, so here it is going to become 2. Then we are running the fourth statement, that is A is equal to twice of A. A is 2, so 2 into 2 is equal to 4. And then we are running finally the second statement, that is B is equal to B plus 1. B value is 2 now, so 2 plus 1, it will make it 3. So what are the possible values after both complete their execution? A value is 4 and B value is 3, using the second order of execution. Let's use this, let's implement this one now. A is equal to A plus 1, so we are going to make it 2, initial value is 1. Then third statement, B is equal to twice of B, so initial value of B is 1, so it is 2. Then the second one, so B is equal to B plus 1, B is 2, so 2 plus 1 is equal to 3, right? And then the fourth one, that is A is equal to twice of A. A value is 2, so it is 4. So what do we get? We are getting A is equal to 4 and B is equal to 3. So this is also one of the value possible. What about this order? Let's do it. So here third one, so B is equal to twice of B. Initial value of B is 1, so it is 2, right? And then we are having fourth statement, A is equal to twice of A. Initial value of A is 1, so it is 2. Then first statement, so A is equal to A plus 1. A value is 2, 2 plus 1 is equal to 3. And then B plus 1, so 2 plus 1 is equal to 3. So what do we get? A is equal to 3 and B is equal to 3. So this is another combination possible. Let's solve this one now. Third statement, B is equal to twice of B, so it is 1, so it is 2 into 1, initial value of B is 1. Then the first one, so A is equal to A plus 1, 1 plus 1 is equal to 2. And then we have second statement, B is equal to B plus 1, so B value is 2, 2 plus 1 is equal to 3. And then finally fourth statement, 2 times A, so A value is 2, so 2 into 2 is equal to 4. So here A is equal to 4 and B is equal to 3. Now let's solve this final order as well. Third one. So b is equal to twice of b. Initial value of b is 1, so it is 2. Then first statement, a is equal to a plus 1. Initial value of a is 1, so 1 plus 1 is equal to 2. And then the fourth statement, a is equal to twice of a. Twice of a, that means a is 2, so 2 into 2 is equal to 4. And then the last one, that is second, b is equal to b plus 1. B value is 2, so 2 plus 1 is equal to 3. What do we get? A is equal to 4 and b is equal to 3. So these are the possible values here. If you carefully see, the unique combinations we have is a is equal to 4, b is equal to 4, a is equal to 4, b is equal to 3. This is again same. A is equal to 3, b is equal to 3. This is again same, right? And this one is also same. So we can have these three possible combinations. A is equal to 4, b is equal to 4. Okay, so here this is possible. Then a is equal to 4, b is equal to 3. A is equal to 4, b is equal to 3. Then a is equal to 3, b is equal to 3. Yes, this is possible. So we can say a is the answer. But let's just see other options as well. A is equal to 3, b is equal to 4. That is not possible here. So option B, due to this, we can say this is not the correct answer. This is possible. This is possible, but this is not possible. So option C is also correct. And this is also not possible. So option A is the correct answer here. I hope it is clear to all of you how to solve these type of questions. Let's proceed to the next question now. That is based on fork and wait system calls. And these types of questions, multiple questions I have solved in my OS lectures, so you can watch them and you will be able to solve. If you have attended those lectures, you will be able to solve these type of questions very easily. So let's solve this question now. Consider the following code snippet using fork and wait system calls. Assume that the code compiles and runs correctly and that the system calls run successfully without any errors. So this is the code given to you. Int x is equal to 3. There is a while loop, x greater than 0. Then there is a fork system call, printf hello. Then wait on null. So here null is given. So as I explained in my lectures also, when null is given, that means none of the process is going to wait. Because if, let's say, instead of this we have mentioned the PID, let's say the process ID, in that case the parent process will have to wait until the child completes its execution. But here null is given, that means none of the process has to wait. They can complete their execution. And then we are decrementing the value of x. The total number of times printf statement is executed, we need to find that. So let's solve this question here. So here x value is 3, so I can say initial value of x is 3, right? Now we can start the execution. So as of now, first of all, let's say we have a parent process. Running while x is greater than 0. So 3 is greater than 0. Yes. So it is going to run. So parent process is going to run, and then fork system call. So there is a fork system call. So let's say here you have the fork system call. So its child will get created. Let's say C1 will get created. And we know whenever fork system call is called, just after that the statements will be executed by child also. Just after that, the statements immediate after the fork system call will be executed by child as well. So we can say printf hello. So printf hello, printf will be executed by parent and printf will be executed by C1 child as well. We can say this, right? Then x minus minus. So x value will be decremented. So here we have x value as 3, but now x value is equal to 2, and here also x value is equal to 2. We can say this, right? Now in the second iteration, 2 is greater than 0. Again we are calling for system call. So what will happen? Parent will stay as it is, its child will get created. So here we have the fork system call, child will get created, and similarly for C1 also fork system call will be executed and its child will get created. Right? Then after that printf hello. So we have this parent continuing here. So printf hello is there. Similarly, let's say here a C2 is getting created and C2 is also executing printf hello. Clear so far? Because both the processes will be executing. Similarly for child also, we have this printf statement and its child, let's say here it is C3. So here also printf will be there. Printf statement will be there. Clear so far? Now then wait, as it is mentioned null, so none of the process is going to wait. X minus minus, so here we can say that for all these processes, let's write like this. So all these processes, here the value of x is 1 now, here the value of x is 1 now, for this process also 1, for this process also 1. Again the next iteration will be executed. 1 is greater than 0, yes, then for system call. So we can say for parent another for system call will be there, so its child will get created, one more child will get created. And for this also, for this C2 also, its child will get created. Fork system call is there, right? So let's say it is C3, let's say it is C4. Fine so far. Similarly for these two process also, its child will get created when we are calling a fork system call, because all these processes will be concurrently executing, right? And for this process also, when fork system call is executed, its child will get created and they are going to continue, right? They are going to continue like this. So now now what will happen? Printf. So printf statement will be there, printf statement is there, printf statement for all the processes, printf statement will be there. That means all are going to print hello, right? And then x minus minus, so we can say x is equal to 0 here. For this also x is equal to 0, for this also x is equal to 0, x is equal to 0, x is equal to 0, 0, 0 and 0. And then again if you want to run 0 is not greater than 0, so execution will stop here. Now we have to find how many times printf hello, how many times hello is getting printed, right? Printf statement is executed. So you can see 1, 2, 3, 4, 5, 6, 7, 8. Then we have 9, 10, 11, 12, 13 and 14. So 14 times printf will be executed. So these are very simple questions once you understand the concept how to build this, right? So again I'm repeating, in my OS lectures I have solved numerous questions, multiple questions based on for system call and wait system call. So do watch those lectures, and if you attend those lectures, if you learn from it, definitely you will be able to solve these questions easily. Okay, let's solve this question now. Again okay, let's first solve this. So right, so let's read the question first. Let's read the question first. Consider a memory management system that uses a page size of 2 KB. Okay, assume that both the physical and virtual addresses start from 0. Okay, assume that pages 0, 1 to 3 are stored in the page frames 1, 3, 2 and 0 respectively. The physical address in decimal format corresponding to the virtual address 2500 decimal format is. So virtual address is given to us, that is 2500. We have to find its corresponding physical address, and they are given in decimal format. In binary it is very easy, but in decimal many students they get confused, and it is also very easy to solve. Let's do it. Let's see what question is saying. So here it is saying that page size is given to us. Page size is given, that is 2 KB, or we can also write it as 2 raised to the power 11 bytes, which is nothing but 2048 bytes. Fine. Now here it is saying that pages are given to us and its corresponding page frames are given to us. So let's say this is your main memory. This is your main memory. That means you are having frames in it, and you have the page table also for mapping of logical or virtual address space to physical address space. So let's say this is the page table you have, right? Now carefully understand, we know in page table the indexing is based on the page numbers and it is starting from 0 always. So let's say we have the page number 0 indexing, page number 1, page number 2 and page number 3. So this is referring to page numbers, and in that we have the frame number bits, also we have the frame number, also we have the extra bits, but it is talking about just frame number. So let's fill that also. So as it is mentioned, page 0 is stored in page frame 1. So here we can say page 0 is stored in frame 1. Page 1 is stored in frame 3. Okay. Then page 2 is stored in frame 2, and then page 3 is stored in frame 0. So this is the page table that we have, and here we know that 0th frame is there, first frame is there, second frame is there, third frame is there. This is the main memory, right? So frame numbers are present here. Clear? Now what is given to us? Virtual address is given to us, that is 2500. Virtual address is given to us, and we need to find its physical address, corresponding physical address. So it's very simple. See, virtual address is given in the decimal format. So what we can do here is, we can find, carefully see here, we have to first find the page number, the corresponding page number. So to find the page number, you have the virtual address. If you divide it by the page size, you will be getting the page number, because we know that virtual address is nothing but the split of virtual address is like that. You have the page offset here and you have the page number here. So virtual address is split into two parts, page offset and page number. So if you divide this virtual address by the page size, you will be getting the page number. And to get the page offset, it is nothing but virtual address, the remainder of that will give you the page offset here. So now carefully see. Virtual address is 2500. If you divide it by the page size is 2048 bytes. 2048 bytes. So it will give you 1 point something, but we are interested in only page number, so it is 1. Fine. And what about the page offset? So 2500 mod 2048. It will give you the remainder, and remainder will come out as 452. You can perform the calculation. Remainder will be 452 here. Now what? Now we know the page number. So page number 1, it is here. So in page table, page number 1, it is present in frame number 3. So frame number 3. So in frame number 3, we have the desired data that we are looking for, or the byte you can say. So here, to find the physical address, now here I'm from the calculation. To find the physical address is nothing but the frame number multiply by the frame size plus the offset, because page offset and frame offset are same. Now why we are multiplying frame number with frame size? Because we want to see this frame number, we want to reach to this frame number 3. Now if I want to reach to this frame number 3, first see how many frames I have crossed. That means on top of this page frame number 3, how many frames are there? 3 are there. 0, 1, 2, 3 frames are there. And in every frame, we know the frame size. Page size is nothing but the frame size. In paging, frame size is equal to page size. So these, on top of frame number 3, we have 3 frame numbers. We have 3 frames. So we can say 3 frames we have crossed, or we can say instead of frame number, we can write frame number as well, or we can say it is nothing but a number of frames that we have crossed. Simple, right? Because it is starting from 0, as it is mentioned in the question, both are starting from 0. So 3 frames we have crossed. So 3 into frame size is what? 2048 bytes plus the offset. Offset is nothing but 452, because page offset and frame offset are going to be same. So if you do this calculation, what do you get? So if you perform this calculation, you will be getting 2048, that is going to give you 6144, and plus 452 is, it will give you 6. So it will give you what? 6596 as the answer for physical address. So physical address is this in decimal format. Now why this formula is like this? Why we have this formula? All the explanation, the detailed explanation of every formula, the intuition behind it, everything I have explained in my OS lectures that you are getting for free. So you can just visit the website. The link I will be providing in the description as well. Okay, directly you can go to there. You can go to that link, and you can enroll for operating system for free, completely free. And I can bet that after watching all the lectures, you will reach out to me and you will say that the content is of, literally it is of best quality, because I have covered each and everything in that. So do watch that if you want to really learn the intuition, the why we are having these formulas. So everything I've explained in detail. So 6596 is the correct answer, is the correct physical address here. I hope it is clear. So that's it from this. We have solved all the operating system questions from GATE 2024 Set 1. And you can join our doubt discussion group, Telegram group. This is public group. You can scan this QR code, you will be able to join, and you can ask your doubts there as well. If you need any guidance, then also you are most welcome. You can reach out to us. You can join our WhatsApp channel also, and you will be getting all the updates. This is the QR code for our website. You can visit the website www.mindmatrix.net.in and start your preparation for GATE 2025 and 2026. We are there for you, and many students have already enrolled. The classes are going on, so start your preparation early so that you don't have to have a regret later on. So start your preparation and give your best in this 1 year. Give your best shot, and do well in the exam. So we are here to help you out. Enroll in our courses for GATE CS 2025-2026 or GATE DA 2025-2026. See you there in the next video. Till then, take care and bye-bye. Thank you all. And one more thing, do like this session and share with your friends, and subscribe to MindMatrix Learning YouTube channel for more such updates and the best quality content. Thank you all. Bye-bye.